Salutations, mini mathematicians! How are we? So happy that you could be here today. We're going to be doing 8.2D already. Wow. Angles and transversals. And this will look pretty similar to some things we did last year in 7th grade. We're going to be working with some of those angle relationships again. So our purpose is to use the following angle relationships to solve for missing angle measures. So we're going to be looking at vertical angles, corresponding angles, alternate interior angles, alternate exterior angles, complementary angles, and supplementary angles. Notice these are angle relationships. So there's a lot of other types of angles you've talked about. You've talked about acute angles. Remember, they're so cute. So first, maybe last year you talked about right angles. And then if you have an angle that's less than a right angle, so if I called this angle ABC, that's a right angle, and I made angle ABD, that's going to be an acute angle. It's less than 90. And you also looked at last year, maybe if we have ABC, and that's a right angle, you looked at angles that were straight angles. So maybe I'll call this angle EBC. That was a straight angle or 180 degrees. And you also looked at angles, again, if we have angle ABC, that's 90 degrees. If we have angle, let's call it GBC, that is more than 90 but less than 180, and anything that's more than 90 is going to be an obtuse angle. So maybe you remember those types of angles, but notice those aren't angle relationships. To have a relationship, you need more than one angle. So taking a look here, we're going to be looking at relationships between angles. If we think about interior, maybe you know someone who's an interior designer. They design the inside. So that is going to be angles on the inside, and alternate exterior. If you think of things on the exterior, that's the outside. So let's get started. So 8.2D lesson, angles and transversals. So transversal is a really important word, and we're going to go over that soon. How do you know when two angles are complementary or supplementary? Draw an example to justify your reasoning. Well, we've talked about those angles throughout the year, and complementary angles are two angles that add up to be a certain degree. Do you remember what angle degree they're going to add up to be? That's right, 90 degrees. Some people remember because the C in complementary, we can put a little dashed line here, and it looks like a 90 degrees. So complementary, two angles are complementary if they add to be 90 degrees. And they said draw an example. So I'm going to show that this is 90 degrees, and I'm going to call this angle ABC, and we'll call this D. So we can say angle ABC and angle, and sometimes with my angle symbol, I'll put a little arc through it so it doesn't look like an inequality symbol. You can do that. You don't have to. I just think it makes it clearer in our communication, and that's really important. So angle ABC, which is this angle, and then if we had angle CBD. Remember, we name angles, the vertex of the angle is always in the center. I could have also called this angle CBA. It doesn't matter as long as the vertex is in the middle. So angle ABC and angle CBD are complementary. However, if we look at the word supplementary, two angles are supplementary if they add up to be, do you remember what it is? You're right, 180 degrees. And some people take the S and they'll make that little dotted line, and you can think about 180, math magic. So two angles are supplementary if they add to be 180 degrees. So I'm just going to use the same picture, and I'm just going to add an angle. Well, I'll write a new picture. So a straight angle is 180 degrees, and we'll have angle A, B, C, and let's just make it W, just to be different. So here we can have angle ACB and angle BCW. They're 180 degrees. They add up to make a straight angle. Notice I don't have to have two angles that are adjacent to be complementary or supplementary. Adjacent means they're next to each other, or maybe they share a side. That's what adjacent means. They're adjacent to each other. Okay, so in the picture below, line L and line M are parallel lines. So to denote that something are parallel lines, if we look at L and M, we use these arrows to show that they're parallel. So for example, if I was going to draw a parallelogram to annotate, since I did it freehand, it doesn't look that great, I'd show that these two sides are parallel with one arrow each, and then I would show that these opposite sides are parallel by giving them two pairs of arrows. And that's how we denote or annotate parallel lines. Annotate, remember that's a symbol for parallel lines. Cool. Okay, so that's showing parallel, and then they're cut by a transversal line. So a transversal, so this is the big word of the lesson, a transversal. A transversal is just a line that intersects any two lines. And what's important here is that we're looking at parallel lines. So a transversal is any line that intersects any two lines. So it's really important that the transversal has to be intersecting two lines. So notice line T here, make it a little bit bigger. It's very tiny. Line T here is the transversal because it's the only line that's intersecting two lines in our diagram. Okay, so let's get back to the problem. So in the picture below, line L and line M are parallel lines, and they're cut by a transversal line we called T. Label the angles formed by the transversal and the parallel lines with numbers 1 through 8. And it's really important because of the questions we have below. It's really important that we label these lines, label these angles the same numbers as each other so that we can discuss their relationships. So we're going to go 1, 2, 3, 4. So we go left to right, top to bottom. So 1, 2, 3, 4. We're going to do that same thing below, 5, 6, 7, 8. Okay, so from here, now that we've labeled them, we can discuss the relationships. So transversals that intersect two or more parallel lines create special angle pairs that have special properties. So it's really important that this transversal is intersecting parallel lines. And even if we had a third parallel line to LM, maybe we'd call it N, these properties would continue. Okay, so supplementary angles, vertical angles, corresponding angles, alternate exterior angles, and alternate interior angles. So these are really important, and we're going to go over what these mean and their special relationships. So if we have a transversal that goes through two parallel lines, we will create supplementary angles. And remember, that means they add to equal 180 degrees. We'll also create vertical angles. And you looked at vertical angles last year. And vertical angles are angles that are created when we have two intersecting lines. And these two angles are vertical to each other. And these two angles are vertical to each other. Do you remember what the relationship is between vertical angles? That's right, vertical angles are congruent. So vertical angles are congruent. And that's really important here because that means they're the same measure. They're the equal measure, which means we can figure out a lot of other angles if we know another little piece of the puzzle. Corresponding angles. Corresponding angles mean they're in the same placement. Just like corresponding sides or corresponding angles in congruent shapes, we have corresponding angles when we have a transversal intersecting two parallel lines. So if I said upper right, what angles are in the upper right? Well, that's angle 2 and angle 6. So angle 2 and angle 6 are in the same placement, which means they're corresponding. And there's a special relationship between corresponding angles. Do you think you see what they are? That's right, corresponding angles are also going to be congruent. So corresponding angles, I guess I can do that in a color since I did all the other ones. Corresponding angles are also going to be congruent, and that means we'll say same placement. Like upper left, lower right, those type of things. Upper right, lower left, etc. So the other thing we have is alternate exterior angles and alternate interior angles. So alternating, meaning if it was on the left, the other one's on the right. If the first one's on the right, alternating would mean it's on the left. And the other thing is interior. Interior always means on the inside, and exterior always means on the outside. So if we take a look at our diagram here, we can think of the inside as being on the inside of the parallel lines. And we can think of the outside of the parallel lines. So this would be the interior. And this would be the exterior. And that's going to be really important because alternate exterior angles have a special relationship with each other. And it's kind of similar to vertical angles. So if we take a look at angle 3, notice angle 3 is on the inside of our parallel lines, and it's on the left. So we want to stay on the inside, but we're going to go to the right. So angle 3 and angle 6 are alternate interior angles. So by alternate, not only are we on the upper left, now we're going to be on the lower right. So we want to change for upper, lower, right, and left. So what's really cool about these angles is, I guess we did this in pink, they are also congruent, meaning that they have the same measure. Okay, so let's take a look. What type of angle pair is angle 2 and angle 6? Let's take a look. Here's angle 2 and here's angle 6. Well, they're probably not alternate interior, alternate exterior because one's in the exterior and one's on the interior. So we can't use these ones. So let's see. Corresponding angles. Well, 2 is in the upper right and 6 is also in the upper right. So angle 2 and angle 6 are corresponding angles. Meaning they're also congruent, which is really cool. Describe the rigid motion that will carry angle 2 to angle 6. Determine the relationship between angle 2 and angle 6. Well, angle 2 to angle 6, when we talk about rigid motion, we're thinking about what transformations? That's right, we're talking about translations, reflections, and rotations. So to go from angle 2 to angle 6, it's just a translation. So angle 2 can be carried to angle 6 by a translation. Hence, the two angles are congruent. And that's really important here because we are going over again that rigid motions always create congruent figures. So let's see, list the pairs of angles that are vertical angles. Okay, vertical angles. So this is good review from last year. So angle 2 is a vertical angle with, that's right, angle 3. Angle 1 is a vertical angle with angle 4. Angle 5 is a vertical angle with, that's right, angle 8. And our last two that we have to look at, angle 6 is a vertical angle with angle 7. So are these angles congruent? Well, I told you they were, but how can we prove they are thinking about using rigid motions? How can I go from angle 6 to angle 8? How would I go from angle 6 to, angle 6 to angle 7? How do I go from angle 6 to angle 7 since 6 and 7 are both vertical angles? Can you think about it? You're right. Each angle pair of vertical angles are rotations of the other. Rotations are rigid motions that create congruent figures. I guess we can say congruent angles. Awesome, really nice job. So describe the rigid motion that will carry, what type of angle pair is angle 3 and angle 6? Okay, so we're going to be looking at angle 3 and angle 6. So here's angle 3 and here's angle 6. Angle 3 and angle 6. Oops, you couldn't see that, sorry. Angle 3 and angle 6. Well, they're both on the interior. One's up, one's down, one's left, one right. That means they must be, you got it, alternate interior angles. Alternate interior angles. So what rigid motion would carry angle 3 to angle 6? What are we doing here? thinking about across that transversal. What rigid motion could we use? Well, we could do a reflection and a translation if we were going to do a combination of rigid motions, which will still create a congruent figure. But we can also carry angle 3 to angle 6 with a rotation. So if we just want one rigid motion, we can say one rotation, or a translation combo with a reflection. All are rigid motions. That create congruent angles. Awesome. So the next angle pair we're going to be looking at is angle 1 with angle 8. Angle 1 with angle 8. So here's angle 1 and here's angle 8. So notice angle 1 and angle 8 are both on the exterior. One's left and one's right. We don't really have an up and a down. I guess we do have an up and down exterior because here's the up and here's the down. So we have up and we have down, we have left, we have right, and they're both in the exterior, which means that these are, that's right, alternate exterior angles. Angle 1 and angle 8 are alternate. Exterior angles. Describe the rigid motion that will carry angle 1 to angle 8. Determine the relationship. We could pretty much copy and paste what we said here on E for G. But we don't have copy and paste with our eyeballs, so let's write it again. One rotation, or a translation with a reflection. All are rigid motions, and therefore congruent. Awesome. And what's really cool is now that we've defined these rigid motions as creating congruent figures, we can use those explanations as to why to prove if a shape or an angle or any type of figure becomes congruent. Okay, so number 3. What I'd like you to do is I'd like you to see if you can troubleshoot through here to find the measure of each remaining angle Oh, I guess I gave you the angles here. Okay, well, let's double check like why that is. So here, if we have measure of angle 1 is 110 degrees, that's because that these are vertical angles. So we'll explain why it is that. So measure of angle is 110 because vertical angle with 110 degrees, which is the given. Cool. Let's look at measure angle 2. Measure angle 2, we can know that it is 70 degrees because you can say it is supplementary with either 110 the given or angle 1. So angle 2 supplementary to angle 1. Okay, so the next one, angle 3, you could say it's supplementary to angle 1 or supplementary to the given 110. I want to use another angle relationship, so I'm going to say that it's a vertical angle with angle 2, and vertical angles are congruent. Vertical angle with angle 2. Okay, let's look at the next one. Measure angle 5. So 5, notice, is a corresponding angle with 110. Or if you wanted to think of it as an alternate interior angle with 110, the given, we can also think about it that way. So we haven't used that angle relationship, so let's do that. Alternate interior, I'm going to use ALTINT for alternate interior. So angle 5 is alternate interior with 110, which is the given. Okay, so now moving on to 6. 6 is 70 degrees, and you could either say it's supplementary with angle 5, but I've already used that relationship, so maybe I will use a different one. Let's think. 70 degrees, well, that's going to be, it's an alternate interior with angle 3. They're both on the inside. This is down and right, and this one's up and left. So alternate interior with angle 3. And again, there's a lot of different angle relationships you can look at with these, but I'm going to try to look at all of them. Okay, so angle 7 here. Angle 7 is also 70 degrees. And it's 70 degrees, and we could use a couple different ones. We can say it's a vertical angle with angle 6. We can say it's supplementary with angle 5. We could say it's alternate exterior with which angle? You're right, angle 2. So alternate exterior with angle 2. And then if we move on to angle 8 is also 110 degrees. And we've used vertical angles, we use supplementary angles, we've used alternate interior and alternate exterior. We haven't used corresponding, so let's say corresponding with angle. And which one is angle 8 corresponding with? That's right, it's with the 110 degrees, which was the given. So now that we've gone over that, what we can start to look at are more equations. Now that we've gone over and we're pretty solid with our angle relationships, let's see if we can write an equation. So given line V is parallel with line W, and remember that's really important that we have these parallel lines, otherwise these angle relationships do not hold true with our transversal. Now we're going to solve for x. So what we need to figure out is what is the angle relationship between these two given angles. One's on the inside, one's on the outside. So we're not going to use alternate interior, exterior. They're not across from each other or adjacent. So we're not going to use vertical or supplementary. So what's the last one that's left? That's right. They are corresponding angles. So corresponding angles, which means they're congruent. So corresponding angles are congruent, so what is our equation going to be? That's right, 4x minus 1 is equal to 89. Congruent means that they're equal to one another. Go ahead and solve for x. If you need to pause the video, you can do that also. Cool, so you probably added 1 to both sides and got 4x is equal to 90. And then divided both sides by 4, multiplied by 1/4, and you got x is equal to 22.5. Notice this isn't degrees because we're not solving for a whole angle, it's just the value of x. It's not a whole missing angle, it's just the value of x, so we don't put degrees there. Go ahead and see if you can solve 5 on your own. Please pause the video. Let's see how we did. So these two angles, if we look at them, they're both on the outside, and one's on the up and the left, one's on the bottom and the right. So these are alternate. They're on the outside, which means exterior angles. And that's really important, meaning that they're congruent to each other. So we have 4x plus 20 equals 60. You subtracted 20 from both sides and got 4x equals 40. You divided both sides by 4, took a quarter of each side. Funny coincidence, we did the same thing. X equals 10. Notice it's not degrees because we're not solving for a missing angle. Cool. So what we can do is, because we know that if we have two parallel lines in a transversal, then we have these congruent relationships, what we can also prove is if those lines are parallel. Because if those lines are parallel, those relationships should still hold. So given two lines, if a transversal cuts through both lines so that corresponding angles are congruent, then the two lines are parallel. So this is one of those if-thens. So we can say if a line cuts through two lines and corresponding angles aren't congruent, then the two lines are not parallel. So let's take a look here. We want to know, are S and T parallel? Well, if S and T are parallel, these angles are, what are they? Well, they would be alternate exterior. But remember, what we need to check on are the corresponding angles. So if this angle is 76 degrees, we need to find a corresponding angle. So a corresponding angle to 76 degrees, and remember it's our upper left, is going to be the upper left here. So let's see if this was 76 degrees. It can't be 76 degrees because this angle, because these are vertical angles, are 77 degrees. Notice I don't have to have parallel lines to have vertical angles. So this is definitely 77 degrees, which means these cannot be parallel lines. So these lines S and T are not parallel because we could say alternate exterior angles are not congruent, and 76 degrees is not equal to 77 degrees, which would be corresponding angles. Cool. Let's take a look at 7. Line P and line Q, are they parallel? Well, we have P and we have Q, and we want to know, are they parallel? Well, 94 degrees, notice this is an exterior angle, and it's on the upper right. And this is also an exterior angle, but it's on the lower right. So there's no relationship directly with these two angles. So I guess we're going to have to do a little bit of math and find some of the missing angles. So we could say, well, 94 and 86 vertical angles, but that's still not helping us because both of these are interior and on the right. So we still don't have alternate interior. We don't have any corresponding angles. So we don't know anything to prove if these are if these are parallel or not. Vertical angles are true for any two lines intersecting. We don't have to have parallel lines. So what we need to look for are alternate interior, alternate exterior, and corresponding angles to be congruent to prove this. Okay, well, I guess we can figure out the supplementary angles. So since these two angles would be supplementary, 180 take away 94 is 86. And we can, oh my gosh, that's enough information for us, you guys. Take a look. 86 degrees and 86 degrees, right here, those are corresponding angles. So we can say line P and Q are parallel because corresponding angles are congruent. And if you want to go into a little more detail about finding the vertical angles and find supplementary angles, you can also do that. What's really important is we need to look at corresponding angles and/or we need to look at alternate interior, alternate exterior. Those are the only relationships that are going to hold when we have parallel lines. Cool. So we're going to get a little bit more into these, and we're going to be starting to look at some triangles. So find the values of missing angles and show all of your work. So what's really important to remember is that when I have a triangle, the sum of all the angles in a triangle are, you got it, 180 degrees. So if you have a triangle X, Y, Z, put little degree symbols here just in case we forgot, we can say that angle X plus angle Y plus angle Z is always equal to 180 degrees. And that's really important to remember. You're going to be using that relationship throughout your mathematical career. So let's see. So since we know that the angles in a triangle add up to be 180 degrees, here we can say that X plus 90, that's what this symbol means, is equal to 180 and solve from there. Combine like terms. 2x plus 90 equals 180. Subtract 90 from both sides. 2x is equal to 90. Take half of both sides and x is equal to 45. And here we can say 45. And if we wanted to write our answer in a sentence, the missing angles each measure 45 degrees. Cool. So now what we need to find is A, B, and C. So this is a pretty cool diagram. And what we have here is because we have these two intersecting lines, a lot of times colors really help me visualize. I'm a very visual learner, and I know some of you are as well. So if we have angle B and angle 87, so always look at what the problem's giving you first. We're looking for A, B, and C. I'm given this. I'm like, oh my gosh, it's jumping out at me. It's telling me that angle B is, you got it, 87 degrees. And that's because it's a vertical angle. Okay, vertical angles are congruent. Okay, so now that we know that B is 87 degrees, what we can use is the triangle relationship that the angles in a triangle add up to be 180 to solve for the missing angles. So we'll have for angle A, 42 plus 87 plus A is going to be equal to 180. So we have 180 equals 129 plus A, which means that A is equal to 51. And I guess since it finds the values of the missing angle, since it's values and not measures, we probably shouldn't put the degrees because it just says values. If it said measures, we put the angles in there. And for angle C, 87 plus 38 plus C equal to 180. C plus 125 is equal to 180. Subtract 125 from both sides, and C is 55 degrees. Oops, just 55. Just really want to put my units. Cool. Okay, let's take a look at 10. Given line C is parallel to line D. Remember, that's really important for us because when we have these parallel lines, that means we have these other relationships. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. So that's going to be really helpful for us to find these missing angles. So the first thing I'm going to look at is, I have a triangle. Okay, triangles add up to 180, but they're all they're unknown, so I can't use that. But is there another relationship I can use? Yes, there is. Notice that these three angles make a straight angle. So I can find angle Z by saying that 38 plus Z plus 25, I'm going to cross my Z's so they don't look like 2's, equals to 180. From here, and that's because it's a straight angle. So from here, we know that Z plus 38 and 25, 63. And Z is equal to 117. I still cannot use the fact that I have a triangle here because I have two missing angles there. But now I can think about a line as being a transversal. So what I'm going to look at is this. And sometimes it's hard to see it when there's this other angle here. So I might draw a quick sketch over here where I have my two parallel lines, and then I have my transversal. And where do we have? We have Y, we have 117 degrees, we have 25 degrees. Does that make sense? Oh, this angle isn't going to be 117, you guys, because otherwise 117 and 25 would have to be 180. So this angle here, this interior angle, is 117 plus 38. So what's 117 plus 38? That's going to be what that angle is. So that's going to be 155. Okay, so then I guess that doesn't really help us. Because all of this angle, okay, so 155 is corresponding upper right, upper right. So this is also 155 degrees. And then 155 is supplementary with Y. So Y is 25 degrees. What we can also look at is we can say Y is an alternate interior angle with 25 degrees. So we know without a doubt that Y has to be 25 degrees. We showed it two ways, supplementary and alternate interior. And sometimes, again, drawing a quick sketch can be really helpful so you can ignore all that other mumbo jumbo. But just make sure your numbers are making sense. Like when we first were writing the numbers, it didn't make sense that 117 and 25 would make this straight angle because we still needed to add that 38 degrees. Okay, so now we still need to, so Y is 25 degrees. So we could just use our triangle, subtract 117 and 25 from 180, but we can also try to use some of our other angle ideas. So if we wanted to find x, we have x, we have 38 degrees. So just looking here, 38 degrees and x are alternate interior. So x is 38 degrees. Oops, that's right. We're not putting degree symbols because it's just finding the value, not the measure. Okay, cool. So let's look at 11. Given line A is parallel to line B, so that's important because then we have congruent alternate interior angles, we have congruent alternate exterior angles, we have congruent corresponding angles. Let me get that word out there. So let's take a look. Measure angle 1. Well, starting with angle 1, I see that it's a vertical angle with 97 degrees. So also know 97 degrees, and that's vertical angles. So if I look at angle 1 then, and I see these parallel lines, thinking about this is on the inside upper right. Ooh, over here we have inside, lower left. It's a different color, purple. I don't know if that shows up as well for you. So measure of angle 1, measure angle 2 are also congruent. So 97 degrees, alternate interior angle 1. Okay, so let's see if we can find from here. Well, nothing corresponds, but now we have supplementary angles. So angle 3 has to be 180 minus 97, 83. We can say supplementary. I'm just use sup. What's up? Supplementary to angle 2. Okay, so now, we have a 90-degree angle here. So now we're working with a different transversal. So I'm going to kind of ignore this. I'm going to move over to my other transversal. So this is 90. What is a corresponding angle to the 90 degrees? That's right, angle 4. So angle 4 has to be 90 degrees. It's a corresponding angle to given 90-degree angle. Okay, and so the last one we're missing is angle 5. So angle 5, what relationship do you want to use with angle 5? So obviously, if two angles are adjacent and on a straight angle, and one's 90, the other has to be 90, and we can say supplementary with angle 5. Can also say corresponding to angle below angle 4, but that gets confusing. We might as well use the angles that are already defined for us. Cool puzzle. That was good. Okay, so let's take a look at 12, and then we can take a peek at our extension. So 12, in the picture below, lines L and M are parallel. So that's going to be helpful for solving our puzzle. L and M are parallel. The measure of angle PAX is 31 degrees. So PAX is 31 degrees. And measure of angle PBY is 54 degrees. What's the angle measure of angle APB? APB. So I don't know what that angle is. Well, let's see if we can extend these lines to create transversals, because right now we don't have any transversals. So what I'm going to do is I'm going to extend line M and line L. Remember, lines go on forever. And then if I take AP and make this into a transversal, I'll call this T1, transversal numero uno. So if I take a look at this transversal, if we have 31 degrees, and that's an interior angle on the upper left. So if I go down here, lower interior on the right is also 31 degrees. And then I've made myself a triangle. So with this triangle, I can say that, maybe I can call this, do I have a W yet? W. I can find angle WPB. I guess we could have done the same thing with extending here to find this angle and this angle. Okay, so just another way we could have done this. So here, 31 plus 54 plus, we'll call this angle WPB is equal to 180 degrees. Because we have that's right, it's a triangle. Triangles add up to be 180 degrees. So from here, we know 31 plus 54 is 85. I'll just leave it as angle. And then, oops, we never put degrees in equations, Mrs. Barr. You are being such an amateur. Step it up. So if we notice that we subtract 85 from both sides and we get 95. So our angle is 95. And then our angle we're looking for is supplementary. Those colors are too similar. We'll use the green. So angle WPB supplementary to angle APB. So we have angle APB plus 95 is equal to 180. Looks like 180, right? And then subtract 95 from both sides. You get angle APB is equal to 85 degrees. Angle APB, notice it says measure, equals 85 degrees. Ta-da! And of course, there were other ways to go about that to figure out the answer, but you should still get the same answer using different angle relationships. Okay, so let's take a look. This is a really pretty cool extension because what we're going to prove is that the angles inside a triangle add to be 180. And I did this last year by cutting out angles and creating a straight angle with them. But let's take a look if we have two lines that are parallel. Notice then we have our two transversals. So I'm going to call CA transversal 1. And if I take a look at transversal 1, because angle C is an alternate interior angle, notice that this is on the inside of my transversals, angle C, and it's in the upper left. So if I go to lower right, I also have angle C. And then if I go over to line BA, I'm going to call that transversal 2. If I take a look at line BA, I notice that angle B is an alternate interior angle down here. And finally, the big finale, angle ABC create a a straight angle, which means that we make 180 degrees. So let's see if we can write this down in words. Line CA is a transversal creating congruent transversal to parallel lines B, C, and DE, creating congruent angles. Angle BCA, which equals C degrees, and angle CAE, which also equals C degrees. Next, we can say line BA is another transversal of parallel lines BC and DE, creating capital C, congruent. Oh, I guess we should have said alternate interior angles. Congruent alternate interior angles, creating congruent alternate interior angles, angle CBA equals B degrees, and angle DAB. Which also will equal B degrees. Creating straight angle DAE made up of the sum of angles A degrees, B degrees, C degrees. Hence, A plus B plus C equals 180. Ta-da! Fabulous. Thank you so much for tuning in. This is 8.2D Transversals and Angles and Transversals. Do your very best. Be nice to everyone. Video bar out.